everyone, good evening. Welcome to India's first animated live tuition. Can you hear me? Yeah, please turn on your camera, everyone. How are you? Yeah, fine. What about you guys? Ma'am, can I see this chat box? Hi, good evening. Today is the first day of my class. Okay, so new students, please raise your hand. You can see one option there, raise hand. So please just click on it and please do raise your hand if this is your first class. Any hand raises, ma'am?
Yes,
okay.
Mariam?
Yeah, hi Mariam, please do unmute yourself and please introduce yourself in 2 sentences. Hello.
Hi, my name is Mariam and I'm studying grade 9.
Okay.
So here, this is my first class in my teacher virtual snap.
Okay.
And I really feel proud and yeah, let's move and see.
Yeah, okay. Welcome to the class, Mariam. Happy to see you. Yeah. Okay, sir. Next one.
Next one is Hedanshi.
Okay. Hello.
Hello, ma'am. I am Hitachi.
Okay.
I study grade 9.
Okay.
Today is my first class.
Yeah. Are you excited?
Yes.
So, which is your favorite subject?
Actually, my favorite is chemistry.
Okay, yeah. Welcome to the class. Happy to see you. Okay, you keep smiling like this. Yeah. Okay. Next one, sir.
Next one is Sujit.
Hi, Sujit.
Hello, my name is Sujit. I'm studying in 9th standard.
Yeah. Okay. Welcome to the class. Happy to see you. Yeah. Next.
1 minute, ma'am.
Okay.
Next one is okay. There is no one left.
Other hand raises. Okay. Yeah. Anyways, welcome to the class, guys. Once again. So we were dealing with chapter number 1, right? Chapter number 1, number systems, right? Yeah. And we already discussed about this natural numbers, whole numbers, then integers, rational numbers, and now we have another topic. And before that, we were discussing a question, right? Yeah. So this was the question that we were discussing in last class. No, not this one. Wait. Okay. Find 10 rational numbers between 3 and 4. So such type of questions, we were discussing such type of questions. So we have 3 and 4 and we have to find 10 rational numbers between this 3 and 4. Before solving this question, what is a rational number? Or let's start with natural numbers. Okay, what are natural numbers? Natural numbers. What are natural numbers?
Okay, Ashlyn.
Yes, Ashlyn, what are the natural numbers?
Natural numbers are numbers that we can count, like from 1 to infinity.
1 to infinity. Yes, very good. So natural numbers are those numbers starting with 1 and goes up to infinity. Natural numbers. So it's 1, 2, 3, 4, etc. Yeah. Now, what are whole numbers? Next one. What are whole numbers?
1 minute, ma'am.
Okay.
Durgesh.
Yes, Durgesh. What are whole numbers?
Are you?
Yes, I'm fine. What about you?
1.
Okay.
And whole numbers are the numbers from 0 to infinity.
Yes, very good. The number starting with 0 and it goes up to infinity, which means along with natural numbers, we are adding one more number which is 0 and we will get the set of whole numbers. Now the next set of numbers is integers. What are integers?
Rehan.
Numbers except 0. Numbers except 0, right? Yeah, okay.
Integers are numbers with negative and positive.
Yes, very good. It includes negative numbers, positive numbers, and what about 0?
Zero is neither positive nor negative, like it's in the middle.
Yeah, it's there. Yeah, very good. So the numbers including all the positive numbers, negative numbers and zero, that numbers are known as, or that set of numbers is known as the set of integers. Now here comes the rational numbers. So what are rational numbers? Ma'am, next one, rational numbers.
Next one is Niranjan.
Okay, Niranjan, what are rational numbers?
Ma'am, rational numbers, the numbers that are in the P by Q form.
P by Q form, and the speciality of P and Q?
Is not equal to 0.
Q not equal to 0, and what about this P and Q? Are they integers or
Ma'am, they can be integers.
integers, and any other speciality? Like something related to this prime composite, we discussed about this prime numbers, composite number, then co-prime numbers, co-prime integers. P and Q are actually,
I think I forgot.
okay, yeah. What about the speciality of P and Q? Anybody? Yeah.
Hanna.
Yes, Hannah. P and Q are?
P and Q are integers.
Okay, like he already told me they are integers, and any other add-ons with this integers? Just integers. Okay. Ayman, P and Q are?
Now P and Q are real numbers.
Real numbers. Okay, so what about this root 2 by 3? This is a rational number?
That's irrational number.
Irrational number. So P and Q are real numbers? No.
No, P and Q are integers. We can say like integers. Integers is correct, I think.
Integers is correct, but yeah, ma'am, that chat box, left side first, yeah. Please scroll down above that, yeah. No, the other one, other chat box. Yeah, before that. Who's that?
Second one. It's Niranjan. Alive. It's Sheikh Abdul.
Sheikh Abdul. Okay, please unmute him. Can you please raise your hand, Sheikh? Yeah, so P and Q are?
Co-prime integers.
Co-prime integers. Yes, P and Q are co-prime integers. So what are co-prime integers?
Two integers
Ah,
who has factors other no except to
like the only common factor is?
one.
1. Very good. P and Q are co-prime integers. We just added one more term with that. P and Q are integers. That is correct. But while learning this equivalent fractions, we have 1 by 2 equal to 2 by 4 equal to 3 by 8. Yeah, 3. No, 6. Okay. Yeah. So while learning about this one, we learned this one, right? Equivalent fractions. Yeah, wait. Equivalent fractions means rational numbers do not have a unique representation in the form P by Q, where P and Q are integers and Q not equal to 0. So we have 1 by 2 equal to 2 by 4 equal to 10 by 20 equal to 25 by 50 equal to 47 by 94. All these are equivalent fractions of 1 by 2. So while learning this one, we learned this one. When we say that P by Q was a rational number, or when we represent P by Q on a number line, we assume that Q not equal to 0 and P and Q have no common factors other than 1, which means P and Q are co-prime. So on the number line among the infinitely many fractions equivalent to 1 by 2, we will choose 1 by 2 to represent all of them. So we learned this in last class. Okay, then we discussed about prime numbers, co-prime numbers, composite numbers, right? Do you remember that? So actually P and Q are co-prime integers. They are integers, that is correct only, but they are actually co-prime integers. Okay, you have this definition in class 10th and there you will learn this. P and Q are co-prime integers. Okay, your answers are correct. P and Q are integers. Yeah, that is correct. But to be precise, they are co-prime. Okay, which means they do not have a common factor other than 1. For example, if we take 1 by 2, they do not have 1 and 2. They do not have a common factor other than 1. But when we take this 2 by 4, they have a common factor other than 1, and that common factor is 2. Okay, so when we say that they are co-prime integers, they do not have a common factor other than 1. Okay, yeah, so this 1 and 2 co-prime, but this 2 and 4, they are not co-prime. Okay, yeah. Okay, so please don't turn on your cameras, everyone. You are not supposed to turn off your cameras during the class time. Your camera must be on throughout the class. Okay, we have a whole team here to monitor you, so please don't turn off your camera. Yeah. Now coming back to this question, no, this one. Find 10 rational numbers between 3 and 4. So we already solved one question like this, and it was like finding 5 rational numbers between 1 and 5, 1 and 2, something like that. So now we have a question, find 10 rational numbers between 3 and 4. So the numbers are 3 and 4. Can you solve this? Muhammad Sheikh, then Khalid, please turn on your camera. Okay, ma'am. Any hand raises?
One second, ma'am. Neha Das.
Yeah. Yes, Neha.
Ma'am, firstly, I have a doubt.
Okay.
Yeah, can I answer that?
Yes.
So, we add 1 plus 10 because they are telling us to find 10 rational numbers,
Okay.
which is 11.
Mm.
And now, 3 by 1 and 4 by 1, we can multiply it by 11,
Okay.
numerator and denominator.
Yes.
We get 33 by 11 and 44 by 11.
Okay. Yeah. Okay.
And then we can take 10 rational numbers in between them, 34, 35, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, yeah.
Yes.
Yeah.
Divided by 11. Okay. Yeah. Very good. Very good, Neha. Yeah. These are the 10 rational numbers between 3 and 4. Yeah. That's it. So whenever you have a,
I
yes.
had a doubt.
Yeah. What is your doubt?
Yeah, so you, for example, 2 by 4 is a rational number, right?
Yes.
But you said that P and Q should be co-prime. 2
Ah.
and 4 are not co-prime, right?
Yes.
Because it has, yeah, so will it still be counted as a rational
Yes,
number?
that is a
or-
rational. Yeah, that is a rational number. But the thing is, this one. Okay, when we say that, wait. Yeah, when we consider this 1 by 2, it has got infinitely many equivalent fractions. So while we represent it on a number line, we only consider this 1 by 2 for all these fractions. That's it. 2 by 4 is a rational number, yeah, but we can just simplify it and write it in the simplest form. So we just say that they are co-prime. That's it. Okay, yeah. Okay, so here the question is to find 10 rational numbers between 3 and 4. So we just take this 3 and 4 as 3 by 1 and 4 by 1. We are just writing it in the P by Q form. As in, like the definition of rational number says that P, like any number of the form P by Q, where P and Q are co-prime integers and Q not equal to 0, is the general form of a rational number. So we always try to write the given numbers in P by Q form. We can always write any natural number as 3 by 1, then 4 by 1, 5 by 1. If we just write 5, 6, 10, 100 means 100 divided by 1. Okay, 100 divided by 1 is 100 itself. So we just try to write this number in P by Q form. So the given numbers are 3 and 4. We just write it as 3 by 1 and 4 by 1. Okay. Then we need to find 10 rational numbers between them. Okay, so that's why we are multiplying the numerator and denominator of the given numbers by 11. You can multiply the numerator and denominator with any number greater than 10. Okay, any number greater than 10 is fine. You need to find 10 rational numbers between 3 and 4. So you just multiply the numerator and denominator of the given numbers by any number greater than 10. Okay, it can be 11, 12, 100, any number. Okay, so basically we just take this 10 plus 1, 11 usually. The other things are also correct. Okay, but sometimes you have to write it in the simplest form. If you are multiplying the numerator and denominator with 100, then there must be some simplifications. That is fine, okay, that is according to your convenience. We usually take one number greater than the given number. Okay, so that's why we are multiplying the numerator and denominator with 11. Okay, so we will get 33 by 11 and 44 divided by 11. Okay, now see this. Denominator is 11 itself. So between this 33 and 44, we have 10 numbers. 34, 35, 36. So just write it as 34 divided by 11, 35 divided by 11. Just like that, you will get 10 numbers. Okay? Ma'am, instead of numbers like instead of this, we can directly do numbers like, yeah, we can do that. Okay, yes, you can do that. 3.1, 3.2, that is fine. Okay, yeah, in your textbook this method is given. Okay, so any doubts about this question? I'm not on a... Okay, here this chat box, another method in my class, another method. What was your method? Just adding them and dividing them by 2. That is your method. 3 plus 4 divided by 2. Yeah, who is that?
Tapu.
Yeah, so what was... Yes.
Now in my school the method works 3 is equal to 3 by 1, then multiply by 10.
Multiply by 10.
Yeah.
Okay. Yeah, wait. So 3 equal to 3 by 1 and then multiply by 10. Okay. Then?
Numerator and denominator by 10 and then we get 30 and by 10.
No, like you are multiplying the numerator and denominator with 10, right?
Yes.
Yes, okay. So 30 divided by 10. Then?
40 by 10.
Yeah, okay. The other one is 4 by 1 into 10 by 10, which is 40 by 10. Okay.
And then in between we find the numbers like 31 by 10 and 32. It goes on.
Okay, 31 by 10. But you will get only 9 numbers, right? 31, 32.
Yeah, but in my school they taught this method.
Okay, but the question is to find 10 rational numbers, and if we do this, we will get only 9 numbers.
Okay, now then I'll do another method.
Okay, yeah. That's why we are multiplying it with a number just greater than this 10. If the question is 10, we just multiply with 11. If the question is 20, we just multiply with 21. Okay, that's it. Yeah.
Okay, thank you.
Yeah. Any other doubts? Yes, Ashlyn?
Ma'am, I didn't confirm, like the 2 by 4 is a rational number, but
Yes.
It's always better to write it in simplified form. Right?
Yeah, yes. In questions and all.
And also, sir, we multiply a number extra and 10 to get 10 numbers, right? If it's below 10, we get less than 10 numbers.
Yes,
right?
yes. If it is 10 also, you will get 9 numbers. So that's why we are multiplying numerator and denominator with a number just greater than 10. Okay. Yeah. Any other doubts? Any other doubts?
No, ma'am.
No. Okay, this is fine, right?
Yes, ma'am.
Yes. Okay, if you have any doubts, you can raise your hands. That's fine. Okay. And you have one more method actually, but don't get confused. If your school is following that method, like 3 plus 4 divided by 2, that method is also there. Adding 2 numbers and finding a number between them. That is also there in your textbook. But if this is convenient, you can follow this. Okay. Yeah. Now the next question is, find 5 rational numbers between 3 by 5 and 4 by 5. You have to find 5 rational numbers between 3 by 5 and 4 by 5. This question was just 3 and 4 were there. Okay. Now here we have 3 by 5 and 4 by 5. So how do we solve this question? Anybody? Any hand raises, sir?
Yes, ma'am.
Okay.
Devyani.
Yes.
Yes, ma'am. So we can put 3 by 5
Okay.
and 4 by 5.
Yeah.
Then we can multiply it by 10.
10. Okay. 3 by 5 into 10 by 10. And 4 by 5
And 4 by
into.
5 also, same thing by
Okay.
10.
Okay.
So we'll get 30 by 50 and 40 by 50.
Okay. Then.
And you can get 31, 32, 33, 34, 35, 36.
Yes.
And then keep on going.
Okay. Yeah. Fine. Yes. So 31, 32, 33 by 50, 34 and 35. So here. Yeah, okay, very good. So here she just multiplied the numerator and denominator with 10, even though the question was to find just 5 rational numbers. You can also do this thing, okay, 3 by 5 into 6 by 6 and 4 by 5 into 6 by 6. That is also fine, okay. Yeah, so any doubts? Okay, if you have any doubts, you can raise your hand. Otherwise, please lower your hands. Any hand raises?
Okay, Mohammed Zuhair, do you have any doubts?
No, ma'am, I don't have any doubts.
Oh.
I want you to answer them.
Okay. Yeah, any doubts? Any doubts? Ma'am, any hand
No,
raises?
ma'am.
No. Okay, so this is fine, right? You can multiply it with any number just greater than 5. Okay, so usually we just do 5 plus 1, 6. So you can multiply 3 by 5 into 6 by 6 and 4 by 5 into 6 by 6. That is also fine. Or any number greater than 5 is enough. Okay? Yeah. Here you can simplify this, but just please don't go for that. That is fine. Okay, so no more doubts, right? Yeah. So let me give you another question. Find 5 rational numbers between 1 by 2 and 1 by 3. So the first case was we just have 3 and 4, just natural numbers. And here we have 3 by 5 and 4 by 5 rational numbers, but the denominator is same. And here we have rational numbers with different denominators, 1 by 2 and 1 by 3. We have to find two numbers, 8:30 p.m. Indian time, okay, IST. Yeah, find 5 rational numbers between 1 by 2 and 1 by 3. Any hand raises?
Yes, ma'am.
Okay.
Haifa Khatun.
Okay, yes, Haifa.
First, 5 plus 1 is 6, so 1 by 2 into 6.
1 by 2 into 6 by 6 and
It will be 6 by 12.
6 by 12, okay.
Then 1 by 3 into 6 by 6 is equal to 6 by 80.
Okay. Then, how do we find the numbers between them?
It will be 6 by 13, 6 by 14, 6 by 15, 6 by 16, then 6 by 17.
Okay. Yeah, Niranjan is raising his hand, I think. Yes, Niranjan, you have the same answer? Who is this, sir?
Not the same.
Same, okay. This is...
No, not the same, ma'am.
Yeah, then what is your method?
Ma'am, we have to change the LCM.
Okay. So,
So it will be 6, so 1 by 2 and 6 by 6.
Okay.
12 by 6, 6 by 12.
6 by 12, okay.
Wait, 1 second.
Okay.
Yes, yes. 1 second, ma'am.
Yeah.
Wait, 1 by 3 is 2 by 2.
2 by 2.
I'll solve this.
Okay. Yeah. So, anybody knows how to solve this question? Okay, wait. Here, while we solve this, 10 rational numbers between 3 and 4. Okay, so you will get numbers like 34 by 11, 35 by 11, then 36 by 11, etc., etc. You will get 10 numbers. So, what is this 34 divided by 11? 34 divided by 11 is actually 3.0909. It goes on like that. So, it is between 3 and 4. When we draw a number line, between 3 and 4, this comes 3.09 is somewhere here. Okay. Then when you divide this 35 by 11, you will get 3.18 something. Okay, so it is here 3.18. So when you divide all these numbers, you will always get some numbers like 3 point something. Okay, decimal expansion will be 3 point something. Yeah, so it is clear that the numbers lies between this 3 and 4. So whatever is the question, when you find the numbers, here we just find 5 rational numbers between 3 by 5 and 4 by 5. So what is this 3 by 5? 3 by 5 is actually equal to 0.6. Okay, and 4 by 5 is actually equal to 0.8. And we just find some numbers here. It is 31 by 50, etc, etc. 31 by 50 is actually equal to 0.62. So it is between the 0.6 and 0.8. When we plot this in number line, it is actually between the 0.6 and 0.8. It must be like that. Okay, so you can just solve the questions and you can just check whether your answer is correct or not by this method. Just try to divide it. If you will get some numbers or some decimal expansions which lies in between the given set of numbers, your answer is correct. Yeah, so what about this question? Just think about this. Can I give this as a homework? No issues, I will solve this in the next class. But yeah, anybody knows any other answers other than the 6 by 6?
Okay, hey Danshi.
Okay.
Ma'am, the method which is used as the LCM.
LCM. Okay.
Yeah. 6 and then 1 by 6.
1 by 6.
And then, no, 1 by 2 into 6.
Okay, 1 by 2 into 6.
Yes.
Yeah,
And
then
1 by 3 into 6.
okay.
And then it's equal to 1 by 12.
1 by 12. This is 1 into 6, which is 6, and divided by 2, you will get 3 only.
Oh.
Yeah. Okay. Okay, so any guesses, guys, about this question? Yeah, I'm not gonna waste time. So, can I solve? Who is that? Sri Lakshmi. Yeah, ma'am, here.
Ma'am, the LCM of 2 and 3 is 6.
Okay.
Yeah, so we can make the denominator 6 and none.
Okay.
So
So,
1 by 2 you should multiply with 3. So you will get 3 by 6.
so numerator
No,
and
3
denominator
by-
with.
Yeah,
Okay.
and 1 by 2 also. 1 by 3 also.
1 by 3 with
With 2.
2. Okay.
2 by 2. So you will get 3 by 6 and 2 by 6.
Okay.
Then you can multiply it with 10.
10. Okay.
3 by 6 into 10 by 10.
Okay.
30 by 60
30 by 60
and 20 by 60.
and 20 by 60. Okay. Then,
Then you get 10 numbers like 21 by 60, 22 by 60.
okay, 21 by 60, 22 by 60, 23 by 60, then 24, etc. Yeah, okay, Sri Lakshmi. What about others? Why this multiplication with 6 by 6 is not possible? Why we are taking this LCM? Okay, just think about this and I will discuss this question in the next class. Okay, just think about this, and if you are ready to answer this question, you can just raise your hand. When we start the next session, you can just raise your hand and tell me, ma'am, we are not dividing or multiplying it with 6 by 6 because of this reason. Okay? Yeah, you can just tell me, just think about this. Don't worry, I will solve this question. Okay? In the next class, I will explain why. If you didn't get the answer, don't worry, I will explain. Okay? But just try to find the answer. Yeah, that is a task for you. Just a challenge. Okay. Yeah, so here this is the question. In the earlier question, it was the denominators were same, 3 by 5 and 4 by 5. So things were so easy. Here it is 1 by 2 and 1 by 3. Okay, so just think about this. Denominator is not same. Yeah, that is the issue, not issue. Okay, yeah, so just think about this. Now, we have the next set of numbers, irrational numbers. So you guys know how to solve this one, right? 10 rational numbers between 3 by 4, like 3 and 4, 1 and 2, 10 and 20. Any such questions is fine. And this is also fine. Like the denominators with the questions with the same denominator. 3 by 5 and 4 by 5, then 10 by 20 and some 12 by 20. All these questions are fine. Just think about this one and we will solve such questions in the next class. Okay? Yeah. Now here comes the next thing, that is irrational numbers. What are irrational numbers? So we already discussed about this natural numbers, whole numbers, integers, rational numbers and all these numbers already discussed. Now what are irrational numbers? Yes, irrational numbers. What are irrational numbers? Any guess? Yeah, sir, we have some hand raises.
Hannah.
What are irrational numbers?
And the numbers which cannot be represented in the form of p by q, where p and q are co-point integers and q is not equal to 0.
Yes, very good, very good. Just the opposite of the definition of rational numbers. So see here, I just added integers because in your textbook it is just written as integers only, but in your class 10 textbook they are written it as co-prime. Okay, so actually they are co-prime. Yeah. Anyways, a number s is called irrational if it cannot be written in the form p by q, where p and q are integers and q not equal to 0. So what were rational numbers? Any numbers of the form p by q where p and q are co-prime or just integers and q not equal to 0, that are known as rational numbers. And here a number is known as an irrational number if it cannot be written in the form of p by q. So rational numbers can be written in the form of p by q and these irrational numbers cannot be written in the form of p by q. Okay? Yeah, just opposite of rational numbers. So, any idea about the set of irrational numbers? Okay, non-terminating, non-recurring. Actually, we are about to start that session in the next class, like topic, decimal expansion of numbers. Okay, so we can start that. Anyways, yeah, your answer is correct. Non-terminating, non-recurring, and the other one is terminating, recurring, or yeah, anyways. Irrational numbers. Any idea about the set of irrational numbers? Can you tell me some examples of irrational numbers?
Muhammad was.
Yes, Mars.
Ma'am, I don't see like I have a doubt.
Yes, what is your doubt?
Ma'am, in the fifth question, find 5 rational numbers between 3 by 5 and 4 by 5.
Yes.
Here, here, I think there's something wrong.
What is wrong?
About 30 by 50 and 40 by 50. I'm not wrong. I mean, shouldn't be like here the answer is 30 by 50 and 40 by 50. Say like 5 rational numbers in there, right? So it's like 30 after 30 by 50, 30 by 30, 34, 35. And what the other 5?
Other one. Okay, so we just need 5 numbers. You can take the other ones. Instead of this 31 by 50, 32 by 50, you can just write 36 by 50, 37 by 50, 38 by 50. Actually, between two numbers, there are infinitely many numbers. So you can just take any of them.
Sure.
Yeah. Okay. So see, guys, if we draw a number line, we just draw this 2, 3, 1, 0 and all this. In between them, infinitely many numbers are there. We can just find 1 by 2 here. Okay. So when we put 1 by 3 is somewhere here. And in between this, we have root 2, root 3. Everything is in between this number line. Okay. It is tightly packed. We can't even count the numbers. Between any two numbers, when we use a magnifying glass to see a number line, between any two numbers, infinitely many numbers are there. We just draw this 1 and 2. Okay, suppose. Between this, we have 1.1, 1.2, see 1.1, 1.2, 1.3, up to 1.9. Okay, now again when we take this 1.2 and 1.3, between this 1.2 and 1.3, countless numbers are there. Infinitely many numbers are there. 1.21, 1.22. So between any two numbers, we can find infinitely many other numbers. Yeah. Okay, anyways, now examples of irrational numbers. Yes, sir.
Abid.
Yes, Abid.
Root 2,
Root 2,
root 3,
root 3. Okay, so such numbers. Root 5, yes. Yeah, okay. Very good. So we have, okay, fine. We have the set of numbers root 2, root 3, root 5. All these numbers are irrational numbers. But what about this root 4? Why did he skip this root 4? Is root 4 an irrational number? Here we have root 2, root 3, root 5. So all the numbers inside the roots are irrational numbers. Is that so? Or why did he skip this root 4? Is root 4 an irrational number? Yes, ma'am. Hand raises.
Hannah.
Yes, Hannah.
Ma'am, actually, root 4 is 2, which is a rational number.
Yes, very good. Root 4 is actually equal to plus or minus 2. Why this is plus or minus 2? Because negative 2 square is 4 and 2 square is also equal to 4. Therefore, we can say that when we take the square root of 4, it is actually either plus 2 or negative 2. Okay, positive 2 or negative 2. So this 2 is actually negative 2 or positive 2, whatever it is, they are actually rational numbers. So root of any perfect square, it is not an irrational number, it is actually rational number. Okay. So root of any perfect square, if we take root 9, is root 9 an irrational number? No. Okay. Pi 33 by 7. Are you sure? It is 33 by 7? Okay, so root 9, it is not an irrational number because this is equal to plus or minus 3. Then root 25, it is actually equal to plus or minus 5. Again, this is not an irrational number. So root of perfect squares are not irrational numbers, but other numbers, they are irrational numbers. So here we have some examples, root 2, root 3, root 5, then pi. What about pi? We have this equation to find the area of circle or circumference of circle. There we use this 2 pi r or pi r square, all this. So what is the value of pi? Pi is equal to, ma'am, ma'am, okay, 1 second. I didn't understand root 4. Okay, who is that? Here a chat box. Okay, wait a second. Root 4. Let's take root 4. Okay, so here we have root 2. Root 2 is root 2 itself. But what is this root 4? In class 8, you have a chapter squares and square roots, right? So when we take 2 square, we will get 4. Okay, so what is actually square root of 4? It is plus or minus 2 is there. It is actually 2 or minus 2. So just consider this 2 first. Root 4 is equal to a rational number, okay, which is equal to 2. That's why this root 4 is not an irrational number. Okay, so generally when we just see a root, square root, we just say that we just think that it is an irrational number. But root of perfect squares are 4, then we have 9, 16, 25, 36, all these are perfect squares. So when we take the square root of such numbers, okay, root of 4, root of 9, root of 16, root of 25, they are not perfect squares. Okay, you can take other numbers, root 2, root 3, root 5, then root 7, everything is fine. But please don't take this root of perfect squares as irrational numbers. They are actually rational numbers because root 4 is equal to plus or minus 2. Root 9 is equal to plus or minus 3. Root 16 is equal to plus or minus 4. For this reason, they are not considered as irrational numbers. They are actually rational numbers. Okay. Yeah, any doubts about this thing? This root 4, root 9? I just saw some comments in the chat box. So any doubts about this? How about root of 9.3 or just 9.3? 9.3 is a rational number. 9.3 is rational, yes. And wait a second. If you are asking about this non-terminating, non-recurring, that is our next topic. Okay, anyways, 9.3 is rational. Okay, yeah. What about the value of pi? Pi is equal to, ma'am, can you please unmute someone?
Christo,
Ma'am, 3.14.
3.14, and in fraction form?
22/7.
22 by 7. Okay, very good. So see, here pi is equal to 22 by 7. P and Q are integers and Q not equal to 0. So pi is actually in the form of P by Q. Okay, P by Q, where P and Q are 22 and 7. So Q is not equal to 0. Then why this pi is considered as an irrational number? Why this pi is considered as an irrational number?
okay, Mitesh,
Yes.
Ma'am, because 22/7 is approximate value.
Approximate, yes. Actually, this 22 by 7 or this 3.5, 3.14, they are just approximate values of pi. Okay, so they are not the accurate values of pi. Just for our convenience, we just take the approximate value of pi. So pi is not actually equal to 22 by 7 or 3.14. Pi is approximately equal to 22 by 7. That is why we just consider it as an irrational number. It is an estimated value or it is an approximate value. Okay, that is why we consider pi as an irrational number. So here we have some examples. Pi and this one. 0.101101110. So this is something related to the next topic. We have decimal expansion of real numbers. There we have terminating, non-terminating, then non-terminating, recurring, and such numbers. So that is why this example is here. I will explain about this example while we discuss that topic. Okay, so you can just take these examples: root 2, root 3, root 5, pi. All these are examples of irrational numbers. Okay, yeah, can you please search that? Okay, so irrational numbers are any numbers which cannot be written in the form of P by Q, where P and Q are integers and Q not equal to 0. So all these are examples of irrational numbers. So any doubts about irrational numbers? If you don't have any doubts, please lower your hands. Yeah. Do you have any doubts? Ma'am, any hand raises?
1 second.
Okay.
Mohammed Zahel,
Yes, Sahel, any doubts?
I just wanted to answer like 5 questions and I forgot to lower it.
Okay, yeah. Any other doubts, guys?
Rishikesh, do you have any doubts?
No. Okay. Any doubts, Rishikesh?
No, ma'am.
Okay. So irrational numbers and rational numbers. So about this thing I will discuss. Okay. Yeah. And do you know, together this rational numbers and irrational numbers, they form another set of numbers. Together they form another set of numbers and it is known as real numbers. Yes, very good. I can see so many comments in the chat box. Wait. All rational numbers and irrational numbers together make up what we call the collection of real numbers, which is denoted by the letter R. Okay. So all rational numbers and irrational numbers together make up the collection of real numbers, which is denoted by the letter R. Okay. Yeah. So rational numbers and irrational numbers together make real numbers. So actually, this rational numbers and irrational numbers is actually the division of real numbers. Okay. Real numbers is divided into rational numbers and irrational numbers. And when we draw this number line, we usually call it as the real line or real number line. Okay, which means when we have a number line, as we discussed earlier, we have a number line. We usually draw this integers or represent the integers in the number line. Okay, usually while drawing this number line, we just put a 0 here, then 1, 2, 3 to the right side, all the positive numbers towards the right side, and the negative numbers towards the left side, -1, -2, like that. Okay. Yeah, so what about the numbers between them? Is there any numbers lying in between these two numbers? Yes, definitely yes. Here we have 1 by 2. Okay, here we have 1 by 2. Then here we have root 2. Okay, we have this representation of root 2 that is coming, representation of irrational numbers in number line. We will discuss about that. So which means generally in between any two numbers there are infinitely many other numbers. Here we can see in between this we have 2.1, 2.2, 2.3 like that it is there. Between this 2.1 and 2.2 we have 2.11 like that. In between any two numbers there are infinitely many other numbers, but every real number is represented by a unique point in the number line. That is why we just take this while learning this equivalent fraction. Instead of this 1 by 2 equal to 2 by 4 equal to 10 by 20, we just take this 1 by 2. Okay, so every real number is represented by a unique point in a number line. We can represent any real number in the number line, whether it is rational or irrational, root 3, root 5, 1 by 2, 0.666, 0.134, any number, every real number can be represented by a unique point on a number line. Also, as we discussed earlier, in a number line there are infinitely many points. Between any two numbers, any two successive numbers that we take, between them there are infinitely many other numbers. But the thing is, all these numbers represent a unique real number. Okay, all these numbers or all these points in a number line, they just represent a unique real number, and all the real numbers can be represented using any points in a number line. Okay, so the thing is, this number line is tightly packed and all these points represent a unique real number, and we can represent any real number in a number line. Okay, and here we know how to represent 2 on a number line, right? We have 1, 0, then here we have negative numbers. We know how to represent 2 on a number line. What about root 2? And again, if it is 1 by 2 rational number, yeah, we know that 1 by 2 was 0.5. So it is somewhere here between 0 and 1 we have 1 by 2. What about this root 2? Okay, we have a topic, it is coming like the representation of numbers, irrational numbers on number line. Okay, we can actually represent irrational numbers on a number line. Okay, yeah, so every number is represented by a unique point on a number line, and also every point on the number line represents a unique real number. This is why we call the number line as the real number line. Okay, this is why we call the number line as real number line. Yeah, we make right angle triangle, yes, 1 each, then Pythagoras theorem, yes, we do like that. This is why we call the number line as the real number line. Okay, yeah. Now we have the representation of irrational numbers on number line. So any doubts about this? Any doubts?
Ashley, do you have any doubts?
Yes, I have 2 doubts actually.
Yes.
You told about between 3 by 5 and 4 by 5, right? And
Yeah.
3 and 4.
Mm.
But those are like numbers right next to each other. But what if it's like 2 by 5 and 4 by 5?
2 by 5 and 4 by 5, you can do the same thing. The denominator is same. 2 by 5 and 4 by 5. So we need to find 5 numbers. Just multiply 2 by 5 with 6 by 6 and 4 by 5 with 6 by 6. Okay, so you will get 12 by 5 into 6 is 5 into 6? Yeah, okay. And here 4 6 are 24, here again 30. So between this 12 and 24, you can just take any 5 rational numbers. 13 by 30, then 14 by 30, any numbers, any 5 numbers you can take. Okay?
Did you say some other name for real number then?
Other name?
Yeah.
No, no.
You said what is
No. For this number line, we also call this number line as a real number line. That's it. Yeah. Okay, so we have this next topic, representation of irrational numbers on a number line. Any other doubts? Oh, that is not there in your syllabus. Okay. What about others? You have this, right? Yeah. In your syllabus it is there, in NCERT syllabus it is there. Yeah, what about others? Do you have this topic in your school, representing irrational numbers on number line?
Yes.
Yes, yes. I can see 1, 2, 3 no's. No, okay. So according to NCERT it is there actually.
Okay, Mohammed Zuhair, do you have any doubts?
No, ma'am.
Okay, fine. So representing irrational numbers on a number line. First of all, let's take root 2. Okay, root 2 is an irrational number, and while discussing the examples of irrational numbers, with the first example we took was root 2. Okay, so let's take root 2 and let's see how we can represent this root 2 on a number line. Sir, can you please play that video? First one, root 2. Yeah, so let's see how we can I even constructed root 2, root 3 and root 5. Okay. Yeah. So first of all we have to draw this number line. Okay. First of all we have to draw this number line. Yeah. And we have to mark the point 0, 1, 2, 3. Positive numbers towards left side and the negative numbers towards the right side. And no. Positive numbers towards the right side and negative numbers towards the left side. Yes. Yes, sir. Yeah, take a compass and stop. Why we are doing this? We actually need to draw a perpendicular line in this one. Okay, at this point 1, we have to draw a perpendicular line. So we are drawing a perpendicular bisector using a compass and pencil. Okay, perpendicular means 90-degree line. We have to draw a line which is perpendicular to this number line, which means a line at 90 degree. That is why we are using this compass to construct 90 degree. Yes, sir. Yeah. So this is nothing but the 90 degree. We are constructing 90 degree. Okay. Yeah. So that will be 90 degree. Now we have to draw 1 centimeter there. That is why we are taking that 1 centimeter on the compass and we are just drawing another line, which means the hypotenuse. You can see a right angled triangle there. Okay, you can see a right angled triangle there. What does this, wait, this sign mean? It means that it is a right angled triangle. You can actually draw a line like this. Okay, but why we are doing this? We need a perpendicular line. Okay, that is why we are constructing a 90 degree using this compass and pencil. Actually, you just have to draw a line, 1 centimeter line here at this point 1. Okay, then you have to draw another line, or which means you have to complete a triangle here. Okay, you have to complete a right angle triangle there. And do you know about Pythagoras theorem? Pythagoras theorem. What is Pythagoras theorem? Anybody knows Pythagoras theorem? Yes, ma'am. Can you please unmute someone? What is Pythagoras theorem?
Oh, it's Umayma.
Yeah, okay.
Ma'am, Pythagoras theorem is the sum of sides of two angles of what? The sum of two sides, angles of two sides, will be equal to the third side.
Sum of angles. No. Suppose I have a right angle triangle here, and this is A, this is B, and this is C. Okay, so mathematically, how can I express Pythagoras theorem?
A plus B is equal to C.
A plus B is equal to C. Okay, let's unmute one more person, ma'am, and ask them whether this is correct or not.
Abhirami.
Do you agree with this, Abhirami?
Ma'am, it's base square plus altitude square.
Yeah, base square plus altitude square is equal to?
Hypotenuse.
Yes, hypotenuse or hypotenuse square.
Hypotenuse.
Hypotenuse.
Yes, ma'am.
Okay. Ma'am, can you please unmute one more person?
Sharia.
Yeah.
It is hypotenuse square.
Yes, it is hypotenuse square actually. So base square plus altitude. What is this altitude? You can also call it as the height. Okay. Base square or the height square. Yeah, or you can also call this altitude as the height. So base, this is the base of the triangle, right? Base of the triangle. The square of base plus the square of the altitude or the height is actually equal to, we call the longest side of a triangle or the longest side of longest side of a right angle triangle as hypotenuse. Okay, so base square plus altitude square is actually equal to the hypotenuse square. So here base is represented as A, so this is not A plus B equal to C. This is actually A square plus B square plus C, A square plus B square is equal to C square. Could we just use a protractor instead of a compass to construct 90-degree angle? Yes, you can use a protractor. Yeah, that is fine. Just take a protractor and place it there and you can just mark 90-degree there. Okay? Yeah, I will also show one video like that. Okay, without using this compass and pencil, you can also use a protractor. Okay? Yeah, that is also fine. Yeah, so representing irrational numbers, yeah, see, this is Pythagoras theorem. So what is, I'm just erasing this. Pythagoras theorem, what is Pythagoras theorem? Pythagoras theorem says that base square plus altitude square is equal to hypotenuse square. Okay, altitude square is equal to hypotenuse square. Yeah, so let's take a right angle triangle. This is a right angle triangle and this here is the right angle. This is the base, this is the altitude or the height and this is the hypotenuse. So we have A square plus B square is equal to C square. Here also you can see a right angle triangle here, right? Right angle triangle you can see here. So let's take that right angle triangle and here see 0 to 1. This distance is 1 centimeter, right? 0 to 1 we have 1 centimeter and here also it is 1 centimeter. We just took that 1 centimeter on compass and we just cut it here, this green line. Okay, up to this it is 1 centimeter. So 1 centimeter, 1 centimeter. In place of this A and B we have 1 centimeter each. Okay, 1 centimeter, 1 centimeter. So according to the Pythagoras theorem, this hypotenuse must be equal to 1 square plus 1 square is equal to this hypotenuse square. Okay, 1 square plus 1 square is equal to hypotenuse square. What is 1 square? It is 1. Again 1 square, 1, that is equal to the hypotenuse square. Okay, 1 square plus 1 square is equal to hypotenuse square, or we can say that 2 is equal to hypotenuse square. When we take this square to the other side, it becomes root 2 is equal to this hypotenuse. So the hypotenuse of this triangle is actually equal to root 2, which means this side is equal to root 2 centimeter. Okay, yeah, this side is equal to root 2 centimeter. Yes sir, please continue. Yeah, now just take that in a compass, root 2, and draw an arc using that length as the radius and you will get root 2 in the number line. Okay, this is how we draw root 2, or this is how we represent root 2 in a number line. Okay, that point where this arc touches this number line is root 2. Okay, yeah.
Ma'am, Abid has some doubts.
Yes, Abid.
Ma'am, it is, I know how to plot root 2 and right, but I don't know how to plot root 3 or above
Yeah, we will discuss about that. Okay, this is the first thing. I will discuss all this root 3, root 5, all this we will discuss in the class. Okay?
Okay.
Yeah. So this is representation of irrational numbers on a number line, and the first thing is root 2. Okay, so we represented root 2 in a number line. Could you show the video again? Yeah, sir, can you please start from the beginning? Okay. Draw a number line, then mark the points 0, 1, 2, 3, etc. the negative numbers. Then taking the 0 as, no, 1 as the center, just draw an arc. Or actually, instead of this, you can use a protractor and mark a 90-degree there. Okay, that is fine. Then just draw a line. This line will be perpendicular to this number line. Then cut a point, that is 1 centimeter. Okay, that is why we are drawing that green line there. Then join those 2 points, taking this as the radius or taking this on a compass, just draw an arc, and the point where this arc touches the number line is actually root 2. So instead of this, okay, wait, you have a number line here. Instead of drawing this perpendicular bisector, what you can do is just mark the points 1, 2, 3, etc. on the number line. Okay, then take a protractor and just place it here, and you can mark this 90-degree here. So just draw a line, 1 centimeter line, okay, using a scale. After marking this 90-degree using a protractor, just draw this 1 centimeter line. Okay, yeah, then this is 1 centimeter and this is also 1 centimeter. Just join this and you will get root 2. This is actually root 2 distance. Okay, then taking that root 2, you can just draw an arc. Everything else is same. Okay, just draw an arc, and the point where this arc touches this number line is root 2. Okay. Yeah. Is it necessary to mark negative numbers on the number line? No, it's not actually necessary. But while drawing a number line, we will mark the negative numbers and positive numbers. No? Yeah, that's why. We just need this 0, 1, 2. That is enough. 0, 1, 2 is enough for drawing root 2. But we just mark the other numbers. Just a negative number or one more number after this 2. Okay? Yeah. So any other doubts? How to write the justification for root 2? Root 2 is irrational. That is in class 10th. Prove that root 2 is irrational. Hypotenuse square will be 2 and hypotenuse will be root 2. Yes, hypotenuse square is 1 square plus 1 square is equal to hypotenuse square, which means 2 is equal to hypotenuse square. Therefore, hypotenuse is equal to root 2. Just like we take x square is equal to 2 means x is equal to root 2. Just like that. Okay, hypotenuse is equal to root 2. Yeah. Any other doubts?
Mehrab?
Yes, Mehrab. Mehrab, do you have any doubts?
Yeah.
Yeah.
Ma'am, if can we represent pi on a number line?
Can you represent 5?
Pi.
Pi.
Yeah.
Yeah, pi is actually, we don't know the exact value of pi, but if it is 3.14, yes, you can do that. Between this 3 and 4, yeah, when we draw a number line, between this 3 and 4, we have 3.14, but that is not the accurate value of pi. So, just to show this will be the value of pi, but that is not the correct value. Okay?
Ma'am, so basically we can't represent pi in the number.
We can represent pi, but the thing is that is an approximate, which means this is not the correct representation because it goes on like 3.14, some other numbers are there, so we can't draw that much lines in this number line. No, it is like 3.141 some, wait, 22 by 7, let me divide 22 by 7, so it will be 3.142857142857114. It goes on and on. Okay, it is never ending. It is not terminating, non-recurring. So this is actually not the correct representation of pi, but we can represent any real number on the number line, but limitations are there. As a human, we have limitations. Okay? Yeah.
Thank you.
Yeah.
I got it.
Okay. Any other doubts? We have some more hand raises, I think. Okay, if you raised your hand to answer my question, please lower your hand. Otherwise, yeah.
Okay, Daniel.
Yes, Daniel.
Teacher, if you want to represent the root 4.2, then how will you represent it on a number line? Because I have a question, so I heard doubt if it's correct or not. The answer.
Yeah. Okay, we can discuss all this in the coming classes. Okay, we will start from this root 2 and we will discuss all other questions like root of 3.1, all these. Okay, like the decimal numbers, then root 5, 5 plus root 3, all these questions we will discuss. Okay, in the coming classes, don't worry. Yeah.
Okay.
Yeah. Okay, quiz time. Yes, wait, we have some hand raises, so let's ask them and after that. Yes.
Okay, Mitesh.
Mitesh, do you have any doubt?
Yes, ma'am. So as you have told that we can't represent pi or number.
We can represent, but that is we can represent any real number on a number line. Okay.
So is pi is a real number?
Yes, pi is a real number.
But then, okay, I got it.
It is an irrational number, and all irrational numbers are actually real numbers. Real numbers is divided into rational and irrational, and so pi is a real number and an irrational number. Okay.
Okay.
Yeah. Next, ma'am.
Reem.
Yes, Reem.
Ma'am, for Pythagorean theorem, can we use that AB square is equal to BC square plus AD square property?
Yes. Okay. If we name it this as ABC, AB square plus AC square will be equal to BC square. Yeah. That is fine. Okay. Any other doubts?
No, ma'am.
No. Okay, will we discuss third chapter? Yes, we will discuss third chapter after completing first and second. Second chapter we just stopped in between the sessions and we started number systems because how to represent 7 square. 7 square, what is 7 square? 49. So just draw the number line, all the numbers, then 48, 49, just like that. Okay, exam time, yes. Okay, don't worry guys, if this root 2 is okay, then we can discuss other numbers, root 3, root 5, then root 5 plus root 3, all other questions we can discuss in the coming classes. Okay? Yeah, don't worry about that. Okay. Yes, sir. Exam. Yes. So root 2 is okay now. Now we can discuss root 3, root 5, other numbers. Okay, don't worry about other numbers. Okay, if this root 2 is okay for you. Yeah. So any doubts from today's session? Any topics? Any doubt? Irrational numbers, real numbers? I have already completed till root 5. Very good. Okay. And after drawing this root 2, root 3, root 5 and all this, we can actually construct a square root spiral. It is very interesting. You can see a spiral actually after completing this root 2, root 3, root 5, root 7, all these numbers. You can see a square root spiral. Okay. We did it in our class. Okay, very good. Completed till root 17. Wow, that's great. We have done that in school. Okay. I did the spiral also. Very good. Yeah. Yes, who is that?
Nadish.
Yes, Nadish.
We have done this in school.
Spiral.
We did like a spiral and we had to design like a peacock as feathers.
Oh, very good, very
like
good.
Art integrated activity.
Oh, very good. Okay. So, Mehrab. Yes, Mehrab?
Ma'am, here we reach hypotenuse, correct? So is it compulsory to get hypotenuse? Can't we just do it simply?
What?
Is it compulsory to get hypotenuse for every single thing? Like, area root 1 square plus.
Okay, I just want to show you that hypotenuse is equal to root 2. Okay, while drawing that is not necessary. You can just take that and draw an arc. Okay?
Okay.
Yeah. Somebody was showing Hanna. Yeah, very good, Hanna. I just saw that. Okay, very good. Square root spiral. And here Niranjan. Yes, Niranjan?
Ma'am, is there a limit to spiral method from we did the class? And I didn't understand the answer that my teacher gave me. So ma'am, like, can you say, is there a limit to the spiral method?
No. We can discuss. Okay, while discussing the square root spiral, we will see that. Okay?
Okay.
Yeah. We can also do it till 360 degree. Okay, I do a parrot and mushroom spiral. Okay. Yeah, who is that? And no, sir. Hand raise.
Rehan.
Rehan. Yes, Rehan?
Ma'am, I want to ask that root 3 the only number which needs like any other root 2 for making the number line?
What?
Like, is root 3 the only number which needs the root 2 to mark number line?
We can mark other numbers. Root 3, root 5. We can mark all other numbers on the number line.
Like, is root 3 the only one which needs another root for marking down number line?
Another?
Root in the sides, like a base or a height for marking down number line.
No. We need for other numbers also we need that. Okay?
Right.
Yeah. I got 10 on 10. Very good. You already attended the exam. Should we do the test? Yeah, you can do that. Okay. Which of the following statement is true? Every irrational number is a real number. Every real number is an irrational number. Every real number is a rational number. Every rational number is an irrational number. So which of the following statement is true? Then square roots of all positive integers is irrational. The statement is true, false, cannot be determined, none of this. Square roots of all positive integers. So it includes root 2, root 3, root 4, root 5, root 6, root 7, root 9, all these numbers. Square root of all positive integers is irrational. So is the statement correct? Now we have next one. Rational and irrational numbers together form real, whole, integers, natural. Then root 9 is dash number, neither rational nor irrational, a rational, then an irrational, none of these. Which of the following is rational? 4 by 0, 0 by 4, root 3, pi. Which of the following is a rational number? Okay, just attend the questions. Yeah, correct answer. I got 8. Okay. Many of you got 10 and some of you got 8. Which question? Answers we will discuss, don't worry. Let them complete, let them finish, and after that we will discuss the answers. I got 8. Which question is confusing you? Like most of the people got this 8 by 10. So which question is confusing you? I also got 8. Yeah, you can't. The first question, I got 8, ma'am. Third. Okay, third question. Okay. This is confusing. Okay. Wait. 10 by 10, very good. Yeah, very good. 8, 10, yeah, very good. I don't know which question. Okay. So let us discuss the answers, then you will understand your mistake. Okay. So, anybody attending the question? Like anybody writing the exam? Second question is confusing. Second question. Okay. Yeah, wait. So, shall we discuss the answers? If you are still attending the exam, please raise your hand. If you are still attending the exam, please raise your hand. First question, I have a doubt. Okay. See, which of the following statement is true? And we have this natural numbers, whole numbers. Wait. Wait. Let me write it here. Natural numbers, whole numbers, then integers. Again. Okay. Natural numbers, whole numbers. Can you see this? Yeah. Okay. Integers. Then yeah, that is fine. Then we have this real numbers is divided into rational and irrational, right? Real numbers is divided into rational and irrational. Okay. Yeah, so every irrational number is a real number. Is the statement correct? Every irrational number, we have root 2, root 3, pi, we have all the numbers. Every irrational number is a real number. Is that correct? Every irrational number, yeah, because this real numbers is divided into rational and irrational. So all irrational numbers are real numbers, right? Is that true? Yes or no? Where should we do the test? Okay, new students, just minimize your Zoom, okay, and refresh your page, and you can see an blue button. You can see a blue button, enter the exam, or you can just log into the website to which you are entering for this class. Okay, you will log into a website for entering the class, no? So just log into the same website, and just below this link for class, you can see this link for exam. Okay. Yeah. Is there anyone who is struggling for this link? Can you please raise your hand if you are still searching for the link? Yeah, Mariam. Can you please unmute her? Here, hand raise. Okay, did you get the link?
Oh no, I didn't get the link.
Okay, so please refresh your page. Just minimize your Zoom. Can you see something there?
No, I can't find it.
Just refresh your page.
If I refresh, I'll get it deleted out of it.
Maybe since you are new to the class, the exam may not be scheduled for you. Maybe that's the reason. So let's see, from next class onwards, it will be okay. I guess so. Okay? Yeah. So these were the questions. Yes, Ayman and Rishikesh. Hand raise.
Ma'am, every irrational is a real number.
Every
Irrational number is a real number.
that is the answer. Okay, so every real number is an irrational number. Is that correct? Every real number is an irrational number. Real numbers includes all the rational and irrational numbers. So if all the real numbers are irrational numbers, 1 by 2.
It is not true.
Yeah.
Irrational number is every real number is irrational, which is not true.
Yes, okay.
Yeah.
Okay, ma'am. Okay, so every real number is an irrational number. That is a false statement, because when we take 1 by 2, this is not an irrational number. So the second statement is false. Then every real number is a rational number. When we take root 2, that is real number, but that is not rational. So the third statement is also false. Then every rational number is an irrational number. No, it's not. Okay? Every rational number is an irrational number. No. First we learned about rational numbers, and irrational numbers is just the opposite of rational numbers, right? We can write rational numbers in P by Q form, but we cannot write rational numbers in P by Q form. So this is the correct answer. Every irrational number is a real number. That is the correct statement. All other statements are not true. Okay. Do not refresh, press the back button. Okay. Mariam, it's okay. These were the questions. Maybe since this is your first class, maybe that is the issue. Okay. Yeah. From next class onwards, it will be okay. Okay, so any doubts about first question? Everybody got the correct answer? Yeah, fine. Now the second question. Square roots of all positive integers is irrational. Square roots of all positive integers. So all positive integers means it includes 1, 2, 3, 4, 5, all these. So when we take root 4, it is a positive integer. Square root of 4 is plus or minus 2 and that is a rational number. So square root of 4 is not irrational, it is rational. So square root of all positive integers is irrational is a false statement, right? Square root of this 2, 3, 5, that is okay, but square root of this perfect squares, root 4, root 9, root 16, root 25, all these are rational numbers. So the statement is false. Okay, got it? Yeah. Now the third question, rational and irrational numbers together form? Together form? Yes, real numbers. They together form the set of real numbers. This real numbers is actually divided into rational and irrational. So they together, this rational and irrational numbers, they together form the set of real numbers. Root 9 is? Root 9. Root 9 is option number 2. Yes, root 9 is a rational number. Why? It is a perfect square. So root 9 is equal to plus or minus 3, which is rational. Therefore, root 9 or root of any perfect square. Here, root of any perfect square. Okay, root of any perfect square is actually a rational number. Root 9, root 16, root 25, root 36, root 81. All these are rational numbers. Okay, now the last question. Which of the following is rational? Which of the following is rational? Yes, 0 by 4 is rational. 4 by 0 is not defined. Okay, 4 by 0 not defined. Root 3, we know that it is irrational. Pi is also irrational. So the answer is 0 divided by 4, it is rational. Division by 0 is not defined, so this is not a correct answer. 0 by 4 is actually a rational number. 4 by 0, no. Division by 0 is not defined, right? I got all questions correct, but I got 8 by 10. What about the last question? You just clicked all the right answers? Ma'am, we have some hand raises.
Neha.
Yes, Neha?
Ma'am, actually I answered every question correctly, but then I still got 8 by 10.
Okay. All questions were correct.
Yeah, every question was correct.
Okay. So let me check, Neha. Okay.
ma'am.
Many of you face the same issue. Even I choose all the right options, but I got 8. Okay. So let me check, ma'am, even for me. But many of you got 10. Some of you got 10 and for others you are facing this difficulty. Okay. So let me check, guys. Okay. I got 10 out of 10. Yeah. Okay. Yeah. Okay. 0 by 4 is okay because condition is q not equal to 0. P can be equal to 0. Okay, here P is equal to 0 but Q is not equal to 0. That is okay. While considering this rational numbers and the definition, Q was not equal to 0 but P can be equal to 0. Yeah, I know. I chose everything right but got 6. Okay. So let me check that. Okay, don't worry about that. Like, I don't know what happened. Maybe some technical issues. So let me check. Okay. Yeah. Okay, so see you all in the next class. In the next class, we can discuss about this root 3, root 5, all these. Okay? Yeah. And until then, take care. Good night.